In this entry, we're going to be talking about geometry and the way geometry and algebra kind of combine. So we have figures in geometry, right? We have parallelograms, rectangles, squares, what have you. And we can start drawing figures in a coordinate plane and doing stuff with them. Okay? And what we do with these figures is called transforming. So we're taking one figure and we're transforming it to a different figure, and that new figure is called an image. And we're going to do it with a graph, so use geometry that way, and then we're going to show it algebraically with the coordinates. So first, let's go over the definition of a type of transformation, which is called a translation. So the definition of a translation, it's a type of transformation like we're changing a figure, that slides every point of a figure the same distance in the same direction. The new figure is called an image. Okay, so that's the definition of a translation. And what's important here is that every point on that figure, when we slide it or when we translate it, goes the same distance in the same direction. Okay. Otherwise, if they went a different distance in a different direction, our figure wouldn't look the same. In your packet for translations, you should have been given this sheet. What we're going to do is we're going to cut out all of these boxes. Okay, so we're going to cut this one out with the rounded edges, so just cut around the dark line, right? Cut this out too, okay, and then these three boxes here. Now that these are cut out, we're going to take these three and put them aside for now. Okay, and we're going to work with this one and this one. What you're going to do is you're going to fold it down along this axis, which would become the y-axis. And you want to get it really, really tight on there. Okay, so be as precise as you can. So you have that fold just like that. Okay, and now what you're going to do is take this fold here and you're going to line it up with the y-axis on this full coordinate plane. So it kind of makes a copy over it. Okay, and now we fold it out, fold it in. For this example, what we're asked to do is take the figure PQRS and do this translation to it. Now you might be confused of what is x plus 6 and y minus 2. How do we kind of relate that into words? Typically, if you're asked to translate a figure, you're going to be given how much to move it, like 3 up or 2 to the left, right? And there are two different ways to show a translation. There's by words, and then there's using this format here about just saying how the coordinates change. Okay? Now, the way that you would say this is to move the figure PQRS six units to the right and 2 units down. Okay, and let me kind of explain why it's to the right. So it's really similar to when we are counting slope. So when we count slope, if we count up towards the positive numbers, then that's a positive direction. If we count down towards the negative numbers, it's a negative direction. Okay? Same thing with x. If we count to the right, it's positive towards the positive x values, and to the left would be negative towards those negative x values. So, whenever you're trying to figure out which way to go or how to go from this form to this form, if you're asked to go up or to the right, it's always going to be plus, like x plus 6 or y plus 2. If you're asked to go down or to the left, that's going to be negative. So x minus 6 or y minus 2. So we have the figure PQRS, and just so we can see it better, I'm going to color it in using my pen in orange. There we go. Okay. Now, what are the coordinates of PQRS? So we're going to write that down in this margin here. So P is at -2, +3, so -2, comma 3. Q is at -2, comma 1. R is going to be at -1, 2, 3, -3, +1. And then S is going to be at -3, +5. Okay, so I'm going to show you the two ways that we do transformations. We're going to first do it with the coordinates. So we're asked to move PQRS 6 units to the right, which is x plus 6. We're adding 6 to the x value. So -2. -2 plus 6 would give me 4. And we're subtracting 2 from the y value. So this would be 3 minus 2, which would give me 1. So the new p, or p prime, would be at 4, comma 1, which is right here. And I'd label that p prime. And if you were to just count, well, I'm taking p and I'm going 1, 2, 3, 4, 5, 6 to the right, and 2 down. So of course the other way to do it is to just count 6 to the right and 2 down and get this whole figure. But it's important to know how to do it with the coordinates, because once you get into Algebra 2, you're not going to be just translating images, you're going to be translating functions. Okay, so it's important to know how to do translations with both the coordinates and with the geometry. So let's keep going. I'm adding 6 to all of these x values. -2 plus 6 again is 4. And subtracting 2 from the y. 1 minus 2 is -1. So that means my new q is at 4, -1. So q prime. And then I keep going. -3 plus 6 is +3. 1 minus 2 is -1. So that's 3, -1. And that is r prime. And finally, s, which is at -3, 5, would go to 3, 3, 3, 3. And this would be my new s, or s prime. Okay, and what I'm going to do is just, because I made this one a figure over here, do the same thing. And I'm going to color that in, let's do it in green. And you can see, if we were to just count, every single point should be moved in the same direction, the same distance. So let's check S. 1, 2, 3, 4, 5, 6. So 6 to the right, and down 2. R, right? 1, 2, 3, 4, 5, 6, and down 2. So there you go. So every single point is moved the same direction, the same distance. And what's neat about this foldable is when you fold it in, Okay, you should see the correct answer right here if we were to color this one in too. So when you look back, you'll be able to see a translation, 6 units right, 2 units down, and be able to open it up and see how the coordinates change given that you were moving it x plus 6 and y minus 2. Okay, so you're going to put either tape just this back down, okay, or you can put glue on the back, but it's really important that you make sure that this can fold up so you can see. On the left hand side, you've got these 3 problems here, okay, and you can either tape or glue them in. Normally what we do is like you do your own problems on the left hand side, we do notes on the right. I'm going to actually go through this one with you. Now in this one here, I'm asked to translate triangle ABC, right 5 units and up 3 units. So I'm going to show you a tool that you can use. We have this stuff called patty paper, and it's just wax paper, but it's nice because you can see through it. Okay, and you don't need the whole thing, so I'm going to have you cut it into fourths and just use 1/4 of the paper. And what I want you to do is label where A, B, and C are right down here. These are original X, Y points. So these are the original X and the original Y before we did any type of translating or moving around in the coordinate plane. Now that you've cut it into fourths, please don't throw away that extra wax paper that you have, the patty paper, or transparency paper is usually what I say. You have a pocket in your book, okay, it's part of your book, you can just stick it in your pocket so that you can keep on using the patty paper for all these problems. So I'm asked to translate triangle ABC to the right 5 and up 3. So what I'm going to do is I'm going to just trace it. So I'm going to trace ABC, and I'm going to label A, B, C. Now it's important to label those points, not so much when I'm translating, because it's going to be easy to see kind of where that one's going, but it's important to do it because we're going to end up doing some reflections, some rotating, and it's going to be confusing to figure out what coordinate goes where. And now we're going to take our figure that we've traced, and we're going to go to the right 5 and up 3. So choose a reference point, which is usually going to be a point on your triangle, and we're going to move 5 units to the right. So 1, 2, 3, 4, 5, and then 3 units up. 1, 2, 3. And that should be the coordinates of our new figure. Okay. And what you can do, what I'm going to do is take a piece of tape, and I'm going to put a piece of tape over this patty paper so that it lifts up and I can see where it should be when I translate it. And if it kind of cuts off or goes into this problem here, you can just cut it up a little bit. Okay. Now let's take a look at how A, B, and C changed. Point A went from -5, -6 to our new A, which is 0, -3. B went from -3, -2 up to 2, 1. So our new B went to 2, 1. And lastly, our new C from -1, -6 to 4, -3. which makes sense because when we're asked to translate 5 units up, or sorry, 5 units to the right and 3 units up, we're taking x and y and we are adding 5 to x and adding 3 to y. So there's my translation. If you don't like using the patty paper, you can also just count. Okay, so we have A. If you're asked to go to the right 5, you can count 1, 2, 3, 4, 5, and then up 3, and label your new A. So you can do it both ways. However, when you're doing these problems, I do want you to fill out this table that shows that you understand that the coordinates go from here to here based on this rule. Okay? And you're going to finish off the entry by translating triangle JKL, 3 units left and 4 units up. J is going to go off this grid. It's okay, it's supposed to happen. Just estimate where that coordinate is going to be. And then for this problem here, you're asked to describe the translation from QRS to Q prime, R prime, S prime. So from this figure to this image, describing the translation. I want you to do it both ways. I want you to do it in words. Okay? And then I want you to do it algebraically. What happens to X? What happens to Y? And then when you're finished, you're going to have your teacher check your answer and you can move on to the practice.